Okay, welcome to graphing a more difficult cotangent graph. And I picked a fraction that's not as nice as, let's say, a pi over 4 or pi over 2 for a phase shift. But we're not going to be intimidated. We can subtract pi over 3 or add pi over 3. We feel confident about that. So we're going to move ahead here. All right, so just to review, this is just like all other trig functions. This 2 is going to be our dilation, or our vertical stretch in this case. So instead of going up to 1, it's going to go up to 2. This pi over 3 is going to be our phase shift. And since it's positive, we're going to be moving to the left pi over 3. And this 1 is our vertical shift. And since it's positive, we're going to be moving up 1. Okay? All right, so the dilation is 2. Phase shift, we're going left pi over 3. And our vertical shift is up 1. Their b value is 1, so our period is going to be the same. So if we look back at the starting point, the parent graph of the cotangent, the period goes from 0 to pi, okay? And it's not being lengthened, and the period is not being shortened, okay? Just remember that in trigonometry, we're graphing cycles. So you have a beginning and you have an end. That's what the period is, the beginning and the end of the cycle. And then the cycle will repeat itself and repeat itself and repeat itself. Okay? All right. So, let's see here. First, let me draw a graph. You want to have a basic idea of what this looks like in your head before you start graphing it. So just picture taking this graph. The width or the period is going to stay the same, and it's going to be stretched 2. So instead of going up to 1, it's going to go up to 2. Instead of going down to -1, it's going down to -2. The whole thing is then going to be shifted to the left pi over 3, and then also the graph is going to be pushed up 1. That's essentially what's going to happen. You should be able to visualize it before we start putting it down on paper. Okay. So let's go through this. And it's also convenient sometimes to move things in components, one thing at a time. So I'm just going to move this first asymptote, wherever I have to move it to. The first asymptote is at 0. I'm going to have to move it to the left pi over 3. And then, well, that's it. If I shift an asymptote up 1 or I do a dilation, you're never going to know it. So all I really have to worry about is shifting it to the left pi over 3. And since we're starting at 0, that's pretty easy. It's going to shift over to negative pi over 3. Okay? We are literally just doing 0 minus pi over 3. Okay? And then let me go ahead and make my asymptote. Okay, now, the next one might be a little bit more difficult. Normally, this asymptote starts at pi, and it's got to shift to the left pi over 3. It's a little bit more difficult, but what we're doing is we're doing pi minus pi over 3. And this involves a little bit of something called common denominators. So this would be 3 over 3 pi minus pi over 3, and that gets us to 2 pi over 3. Many of you might be able to just do this in your head. So I'm going to go ahead and mark that. That's 2 pi over 3, and then draw on the asymptote. Good. Now, let's figure out the 0 point. Normally, on a normal cotangent graph, it's at pi over 2, but it has to be shifted to the left pi over 3, and then it's also going to have a vertical shift of 1. I don't worry about the dilation for this center point because it's a 0 point. We're just going to have to phase shift it over and then shift it up. The dilation only comes into play to all the other points. But this first one, because if you take 2 times 0, you get 0, the dilation doesn't really affect anything. Okay, so I'm starting, I need to say I'm at pi over 2, that's where I normally have my 0 point, but I'm moving to the left, pi over 3, and this, common denominators. So this is equal to 3 pi over 6 minus 2 pi over 6, and that means I'm at 1 pi over 6. And that's where the center of this graph is. So I've shifted it. I'm going to move it up 1, and then that's the new center of my graph. Okay? So I've shifted negative pi over 3, and I've gone up 1. Okay, I've got the new center of my cotangent graph. Now again, your knowledge of your parent graph is going to help you eliminate a whole bunch of work. We do have to figure out where, we do have to go to the right and to the left, we've got to go pi over 4. So we do have to do a little bit more fraction work. So I'm going to do pi over 6 plus pi over 4. Okay, and that is going to get me 2 pi over 12 plus 3 pi over 12, which is equal to 5 pi over 12. Okay. So I'm just going to stick that in the middle. This is 5 pi over 12. And once I have that, though, it's actually pretty easy. I know that if I go to the right, I normally go down 1, but since I'm dilating 2, when I go to the right, I have to go down 2. 1, 2. That's the dilation. It's increasing the amount you're stretching that. Okay, now I'm going to subtract pi over 4. So pi over 6 minus pi over 4. That's 2 pi over 12 minus 3 pi over 12, and that's going to be negative pi over 12. So here, at negative pi over 12. Normally when I go to the left 1, I would go up 1, but since I'm dilating 2, I'm going to go up 2. So I go over to negative pi over 12, and go up 2, and there's my other point. And from here you can sketch in the cotangent graph. Okay? So that covers graphing the cotangents with a phase shift, a vertical shift, and a dilation. Okay? And it really boils down to your knowledge of the parent graph, knowing where the asymptotes normally start out at, knowing where the 0 point starts out, and understanding that normally you go left pi over 4 and up 1, and right pi over 4 and down 1. So the dilation is going to stretch that out vertically. Okay, thank you. Please don't forget to add any comments you might have at the top of the video page on suggestions for improving the videos. Thank you.